Howdy, it's Tubalcain once again, and this is a two-part video dealing with how to make a 90-degree notch in your workpiece. Now, quite often you need to do this, and there are many different ways of doing it, but looking at some of the samples I have laid out here, you can see that you need to do this if you're doing repair jobs or making certain kinds of projects. So there's a 90-degree V in a tap wrench and in a lathe dog. There's all kinds of V blocks that require it. Crotch center, and you're going to see it quite often in drill press vices where they have one of the jaws with 90-degree V used to hold round stock. What prompted me to make this video and this demonstration is that in the following video I'm going to show you how to make the movable jaw, which is missing in this Greenfield tap wrench, and another one of the models will look like this, and that's really what I'm modeling it after, and I'll be making this movable jaw out of tool steel. So be sure and watch that video, and there's several different ways of approaching that. This 90-degree notch is very easy to make if you have the right cutting tools. For instance, here's a drill mill, and that's easy to center. The problem is centering it within the work, so that's what I want to show you how to do. And these are available in 60-degree and 90-degree, but they're rather expensive when you get into the larger size that you might need. So a ½ is about $40 or $50, and when you get into a 3/4 wide, it's about $150. And if you have a horizontal mill, you're probably going to use a double angle cutter as shown in this old Brown & Sharp catalog, and those were available in, as you can see, different degrees here, but I'm interested in the 90, and this goes on the arbor of a horizontal milling machine, and it only costs $7. Oh, that's right, that's from 1938. That's about a $250 cutter. But the problem we're solving here in this video is how to make that V-notch 90 degrees with an end mill, because everyone has end mills. Everyone that has a milling machine has end mills. They're cheap, easy to find, and that's what we want to use. Okay, and that's going to give you 90 degrees. Most of you have probably been doing it by the method where you just do an accurate layout and mill to the layout lines, and that probably is fairly accurate, and later on I'm going to show you how to measure that to see if you're truly on the center. Sometimes it doesn't matter if you're exactly in the middle. It just doesn't matter, but other times you want it right on spot. So let's talk about using an end mill and setting it up in the vertical mill. Let's see how to do that and to find the center. Here I am over at the milling machine, and it's very important that when you're doing this method that the end of the work be perfectly square. So I'm going to mill it off square. And this could just as well be done in a 4-jaw chuck. Matter of fact, it probably would be better. Okay, I'll remove the burrs. This is 3/4 inch square cold roll steel, and it's just a sample piece. Now this is how to set the work up, and this is again 3/4 inch square, and it's only 4 or 5 inches long, and you're limited to the length because we have to put the work into the vise at a 45-degree angle. If it's too long, the bottom is going to strike the table, and you don't want it to stick up too high here because you will lack rigidity. So using my 45-degree machinist square, and you can certainly use a combination square or whatever you have, but this one is highly accurate. I just lay it into the vise like that, and I'm going to put just a little pressure on the work. hold it on the square, and I want a minimum amount sticking out, but that's just fine right there. I'll tighten the vise, remove the square, and now we have to do just a little bit of calculating. I'm back at the bench to show you how I'm actually going to do this and talk a little bit about the math, and don't let that scare you. We need to touch off. This is held again 45 degrees in the vise. I need to touch off right here and then move in a given amount, but I don't know what that amount is. That's an unknown. Also, I will come down from the top in the z-axis and touch off. It's a matter of going in. And how do I find that? Now this is 1 inch or 7/8 square, but let's pretend that it's the 3/4 inch square for right now. Okay, down to the math of it, and I'm not a math teacher, so I hope this makes sense, but using a trig function book, and these are available everywhere, you can find this on the internet easily enough, and this little book is full of formulas and functions. Don't let that scare you. But looking on this page here, remember trigonometry is just the study of triangles. So we have some givens already. We know that the angle is 45 degrees, and we know that this length here is of C is 3/4 of an inch. That's 0.750 for this 3/4 inch stock. But in fact, we want to find the middle, so I'm going to change C, the value of C, to 0.375. That's again half of the 3/4. So we have those two, and that will give us B. So we want to find B, which will be the center of the work, right where we have all the crisscrossing there. That's the point that we're trying to find on 3/4 inch stock. All right, let's see what formula we need. Through the process of elimination, I have determined that I want this formula here with a little pencil mark on it, and that will give us the value of B. So the formula is C times cosine of D. Now we already know that C is 0.375, and that we need to find the cosine of D, and that's easy enough to do. That's what I'm going to show you right now, how to find the cosine of 45 degrees. And there's two ways of doing it. If you have trig tables, and there's many pages here, we'll just go toward the back here for 45 degrees, and the cosine right there of 45 is 7.707. And the 60 there is 60 minutes, so forget that. So it's 707. Now I'll show you an even easier way. Everyone in the world has a scientific calculator. They used to cost hundreds of dollars. Now you can get them at the dollar store, I think. But it's so simple. Notice that on the screen here it says degrees. You ever wondered what that degree was for? So let me just punch in 45. And then I'll just hit the cosine button right here. And that gives me that value. There it is, taken out many more places than we need, but you can see it's still 0.707. Easy enough. Doing the very simple math now for this formula, B equals C times cosine of D, filling in the numbers there. B equals 0.375 times that 0.707 that we just found, and the result there is that B equals 266 thousandths. So that means simply that after I touch off here and find that corner, I'm going to move in 266 thousandths, and the corner of the end mill will be on the center of the work, right out here. Then we have to proceed to cut by feeding down and over equal amounts until we end up with the right width here, and I'm just going to cut it to approximately 3/8 of an inch. By trigonometry you can get that exact, but how often would you need the width of your V real accurate? So we're just going to do that by baguesse and bagosh, even though I Probably overdid the math there. I hope that wasn't a turn off to you people. So let's go back to the mill. Now when I said touch off, I suppose you could use an end mill for that, but I'm using an edge finder and use the 1/2 inch diameter edge finder. Since I am using a 1/2 inch end mill, that just makes the tool changing and I don't need to change the collet a little bit easier. Now, how accurate is it to use an edge finder on a corner? I actually have never done it before, nor do I know anybody that has, so a lot of what I'm doing here I'm just making up. By experience, I haven't really done something like this very often, if ever, or it was a long time ago. So let's touch off. Alright, did you see it slide over? So now, looking at the DRO, I'm punching it in to 0 in the x-axis, and I will not be using the y-axis at all. By the magic of television, I have removed the edge finder, which is 500 thousandths, and I put the 1/2 inch end mill in there, so I do not need to compensate here because the cutter is on the corner of the work. Then raising that up and looking at this again, I'm moving over the 266 that we talked about. Right there, and if you don't have a DRO, you can dial it in. There we go. Do you understand now that the end mill is right in the center of the work? All of that math was for that purpose. And since I'm now in the center of the work, I'm going to zero this out. And I can always come back to that when I need to. And the next step now is to raise the cutter out of the way, bring it up over the top corner, come down and touch off, and I'm going to use a piece of 1 inch thousandth thick shim stock just to get my feel there. Okay, so I've touched off right here, and let me show you what to do next. I need to back the cutter away from the work like that, and looking down at the knee now, I'm going to move this in also, or I should say raise it. This is the z-axis, 266 thousandths. So there's 100, 200, and 66 thousandths now. So now I've positioned it, and the corner of the end mill is exactly on the center of the work. But I can't cut yet. I've just got it zeroed out in both the Z and the X axis. So now I want to arbitrarily and capriciously take a 50 thousandths cut. So in order to do that, I am going to raise the knee 50 thousandths. You can't see that, that's off camera. So I raise the work 50 thousandths, and I'm also feeding in 50 thousandths. I'm looking at the DRO, and then I will lock the table in both of those axes. I'm ready to cut, finally. And that can be done so much faster than what this video is. And I'm going to do this without oil so it doesn't interfere with your view. You understand why I moved the 50 thousandths in both directions? And there's my V-notch, and that didn't take off a whole lot of metal, so I'm going to take off another 50. So I'll increase the feed in both axes again. And this is another 50 thousandths. Now, using the stubby little ruler, I'm getting a measurement of about 1/4 inch. So I'm going to take off another 50 thousandths, and that should take me to around 3/8. All right, and that's a total of 150 thousandths in each axis for the final cut here. And that gives me a groove that is about 3/8 wide, and that's what I wanted. If you need it more accurate than that, that also can be done using trigonometry. I'm not going to show that. Now let's go measure it. Alright, I'm back at the bench. That's what it looks like, and again, just a little over 3/8. I've deburred it thoroughly with a file. It has to lay flat, and then I've cleaned the surface plate thoroughly. This is a 3/8 dowel pin, and that's not too critical. And I've already set the Starrett indicator on my surface gauge. It's about 1/1000th over on that side, and on this side also more or less the same. I have to be careful to push this very tightly in there. So the reason I'm doing this is just to show you that that V-groove is in the center of the work, more or less. And that's the tricky, hard part. So in the next video I'm going to put that to practical use when I make this jaw for the tap wrench. But that concludes this video, but stay with me for another 5 minutes or so as I show you how to do it. I'm just going to mill this to the line. This is the one that I laid out earlier, to see how accurate it is. This is optional, so turn this off if you're sick of it, but I will use this method here just to see how accurately I can mill it by the layout method, because I know there's going to be some people that just do not want to get into this trigonometry. So either goodbye right now, or I'll see you in a minute. Alright, I'm over at the mill now. This is the 7/8 square stock, and I'm just going to mill it down to the lines and see how close I can get it centered. I'm just going to mill away willy-nilly here until I get close to the lines, then I'll get a little more serious about it. I have a little more sticking out of the vise than I want because the work is so long. I've got it roughed away fairly close to the line, so what I'm going to do next is just mill down to the line. That is, I'm working now in the Z-axis only, and I'll worry about the other axis when I get down to the layout line. I would like to mill the line in half, but that's not going to happen. Alright, I'm down to the line now, this way. Now I'm taking it in the x-axis to the line. Alright, I believe I'm down to the line. Possibly one more cut. I gotta put my magnifying glass on, and then I will meet you over at the bench. But this totally depends on judgment and experience and accuracy of the layout line and all such things to center that V in this piece. So one more pass and I'll see you at the bench. Okay, there it is. And I have to tell you, I already measured it, and I am absolutely shocked by the results. Absolutely shocked. I'll keep you in suspense for just a minute more, because this was done so quickly. The whole thing, including the layout, could have been done in 8 or 10 minutes. So let me turn the light out here so that the indicator will show up a little better, and I'll use the same 3/8 dowel pin. If I were a betting man, I would say that I would be lucky to get it within 10 thousandths. So the indicator's already set here so that I'm getting I got to zoom in on that just a little bit. It's about 0 there. And it's within 2 thousandths. That's really about how close the other one was. With all of that work, all that math, all of that touching off, and I basically got it as accurate as that with the layout. You could knock me over with a feather. I hope you stuck with me. Well, you did stick with me. I wonder how many people didn't get to see this. Because this is still, let's face it, the way that most people are going to do it, to avoid the math and to speed things up. So that's how to make a 90-degree V-groove by 2 different methods. Now stay with me in the next video as I do the jaw for the tap wrench, because there's a few other operations there too. I'm going to deal with a left-hand thread and a hardened piece of tool steel and all of that. So thanks for watching. This is tubalcain saying so long for now, and I'll see you in my next video, I hope.